Okay, let's dive right in. You've definitely been here before, right? A user is trying to upload a file, everything seems fine, and then, bam! Request too large. It's super frustrating for them, but for us, it's actually a clue. It's our system telling us something's not configured right. So today, we're putting on our detective hats and cracking this case wide open.
And that really gets to the heart of the matter. This isn't just some random bug we squash and move on from. It's a real friction point for your users. And PookieTech puts it perfectly here. It's a signal. It's your system saying, hey, what you're asking me to handle doesn't line up with how I'm set up. And honestly, whether the limit is 1 megabyte or 100 doesn't really matter. What matters is that some boundary was hit, and now we got to figure out where.
So, yeah, let's treat this exactly like a mystery. A request leaves the station, but it never makes it to its destination. Somewhere along the line, a roadblock was put up. So our job? We're going to be detectives. We need to find out who or, what is to blame.
Okay, so before we can start pointing any fingers, we need to map out the crime scene. You see, every single HTTP request goes on a little journey, and the problem is, it can get stopped at any point along the way. So to find our culprit, we've got to trace its path.
And this right here, this is basically our map. A request starts in the browser, then it has to pass through these potential checkpoints. Think of them like security guards, a proxy or a gateway, before it can finally get to our application server. That error message we saw, that's proof that one of these guards stopped it. So our bad guy is hiding in one of these spots.
Which brings us to our official lineup of suspects. Suspect number 1, the client-side app itself. Maybe it has some rule that stops the request before it's even sent. Then you've got the web server, your Node.js, Python, or Java backend, which could be rejecting the payload. And then there's the usual suspect, the one that's really common, a reverse proxy like Nginx or an API gateway. Think of it as the bouncer at the front door of your entire system.
All right, detective. We've got our suspects lined up, and we've got our map of the crime scene. Now it's time to start gathering some actual clues to figure out who did it. Let's get to it.
And believe it or not, our first and maybe most important clue is waiting for us right where the crime was reported, in the browser. And you don't need any fancy forensic tools for this one. Just pop open the good old developer console. This is where we're going to find the smoking gun.
So what you want to do is go to your browser's network tab and find that failed request. The first thing you'll see is the status code, 413 payload too large. That's our confirmation. But here's the pro tip, where things get really interesting. Look at the response headers. Do you see a server header that says Nginx or Apache? Well, that's like finding a business card at a crime scene. It points directly to a suspect. And sometimes the response body itself is a huge giveaway. It might be a generic error page from your proxy or your CDN, literally telling you who blocked the request.
Okay, but what if the browser clues aren't totally clear? What's our next move? Well, our next technique is a bit like something out of a spy movie. We're going to listen for something that isn't there. We're looking for the sound of silence in our server logs.
No, seriously, think about it. You try the upload again, you immediately go check your application's logs, your node logs, your Spring Boot logs, whatever, and for that specific request, there's nothing. Crickets. What does that tell you? It's a massive clue. It means the request never even got to your app. The block had to have happened before it got there. The culprit is definitely upstream.
And that leads us to the final piece of evidence. If you're pretty sure it's a proxy like Nginx, you go check its error logs. They're usually in a spot like var/log/nginx/error.log. And if you see a line in there that says something like, client intended to send too large body, well, that's the confession right there. Game over. Case closed. We've found our blocker. Okay, so now we're experts at finding the problem. Let's talk about how to fix it. And honestly, a lot of the time, the best solution isn't messing with server configs at all. It's about getting ahead of the problem, being proactive, and handling these big files in a smarter way, right on the client side.
So instead of trying to send one gigantic all-or-nothing request, chunking is all about breaking that big file into small, bite-sized pieces. Think about it. If the user's internet connection hiccups, you don't have to start over. You just resend that one tiny chunk. This is way easier on your server's memory, and here's the magic part. Each one of those little pieces is so small, it just flies right under the radar of those pesky size limits.
And don't worry, this isn't some crazy, complicated academic theory. There are open-source protocols like TUS and just amazing libraries like UPI that make this whole thing super easy to implement. Seriously, this is the robust, production-ready way to handle files that are actually big.
Now, chunking is definitely the way to go for really big files. But let's be real, sometimes the fix is way simpler. If your users are just trying to upload a file that's like a little bit over some low default limit, the most direct fix is just to, well, raise the limit on the server. And just like our detective work suggested, a super common culprit here is Nginx. Look, it's an amazing tool, but it's built to be secure and performant out of the box. And to help prevent things like denial of service attacks, it ships with a tiny default body size limit. We're talking 1 megabyte usually. 1.
But now that we've found our guy, the fix is, well, it's just beautiful in its simplicity. You just add this one little line, client max body size, to your Nginx config file. Set it to something reasonable for your app, maybe 100 megs, reload Nginx, and that's it. Problem solved.
Okay, but what if your logs showed the request did make it to your app? Well, that means the call is coming from inside the house. The block is internal. So if you're in the Node.js world using Express, the place you want to look is almost always your body parsing middleware.
For regular JSON payloads, it's as easy as adding a limit option to express.json, just like you see here. But, and this is a big but, if you're handling actual file uploads using something like Multer, you have to remember to configure the size limits inside Multer's options too. That's a common gotcha.
And hey, what about the Java world?
If you're using Spring Boot, it's a very similar story. The fix is just as simple, but instead of tweaking code, you're probably just going to be editing your application properties file.
You just hop into your application.properties and set a couple of values, like max file size and max request size, to whatever makes sense for you. Make the change, restart the app, and you are good to go. So let's bring it all home and go over our detective's handbook one last time. The number one rule: diagnose first. Don't just start changing config files randomly. Use the clues. Your browser's network tab is your best friend. Remember, if your server logs are empty, the block is happening upstream. It's probably a proxy. And if you know you need to handle genuinely large files, please do yourself a favor and look into a proactive client-side solution like chunking. It'll save you so many headaches. And finally, when you do need to increase the server limit, do it deliberately. Know why you're changing it, not just guessing. And that really leaves us with one final big picture question. Sure, changing a number in a config file is easy. It's a quick fix, but what is that error message really telling you about your system's architecture? Is simply increasing a limit the right long-term solution, or is it a sign that you need a more resilient, more scalable way to handle large data? That's a question worth thinking about long after you fix this one bug.